Hi everyone, I'm Carolyn Parkinson. I'm an assistant professor at UCLA, and I'm really excited and honored to get the chance to be part of this workshop and to get to speak alongside scholars whose work I admire so much. So I'm really thankful for the organizers for putting together this workshop. Both the topics of this workshop, so naturalistic neuroimaging and individual differences, are topics that I'm really excited about. And the other speakers in this workshop have really laid the foundation for a lot of the work that I'm going to be telling you about. And they're also doing some really amazing work sort of pushing this research forward, both with respect to the sophistication of their methods and the creativity of their approaches and their perspectives. So I'm really looking forward to just watching everyone's talks once they're posted. And before I get started, I want to be sure to thank the many people that were involved in the projects that I'll be telling you about, as well as our various funding sources. Everything that I'm going to be sharing with you today is really a team effort. And so really broadly, the common thread that ties together the various pieces of work that I'm going to be telling you about today is that this work is all concerned with the interaction between our cognition as individuals, or in other words, information processing within individual brains, and the webs of relationships in which each one of us is embedded. And I think that understanding this is really critically important to understanding some fundamental aspects of everyday human thought and behavior as it unfolds in naturalistic settings, so out in the real world when we're going about our day-to-day lives. Because as you can imagine, for example, if you consider like even the simplest possible social encounter that you might have in any given sort of day of your life, especially in pre-COVID circumstances, when you might have been walking down the street and you happen to bump into someone, how you respond to this person. So things like how much attention you might pay to this person, if you're going to stop and say hello, what you might speak about if you were to stop and say hello, and even things like how much you might trust or confide in this person. These things all depend in part on aspects of this person as an individual. So maybe things like her appearance or personality traits or your knowledge of her likes and dislikes and so on. But how you perceive and interact with her is also going to depend on your relationship with her. And one aspect of this is, how close you guys are to one another. So is this one of your close friends? Is it a loose acquaintance? Is it just a friendly stranger? So there's the notion of social closeness. There's also aspects of social status, right? So is this your boss? Is it an old friend? Is it a student in one of your classes? So of course, it's not just characteristics of individuals in isolation that shape our thoughts and behavior in our everyday lives out in the real world. So it's not just the question of our own direct relationships with other people that are important. It also gets more complicated than just our direct relationships with other people, because each of us have our own sets of social connections. And then those people are connected to each other and to others. And so we're embedded in this rich fabric of social ties. And information about someone's position in this fabric of social ties in our social networks can really matter for our real world behavior. Some people might be better connected than others, and we might have to then modulate our behavior accordingly, because now there might be more reputation costs for doing things like divulging sensitive information to those people or for offending or wronging them. And some people have even argued that the cognitive demands associated with tracking and encoding and managing relationships in our real world social networks might have played an exceptionally significant role in the evolution of the human brain. And so this is arguably something that's really important to us as a species, and it's something that we seem to be concerned with pretty much all the time. And yet we really don't know very much about how we understand, how we shape, and how we're shaped by the patterns of real world social relationships that surround us as we go about our day-to-day lives. So to begin to try and answer some of these kinds of questions, we generally start by taking an approach that kind of looks something like the following. So we get everyone in some bounded community, like a school or a dorm or a village, and we ask them who their friends are, typically giving them more specific criteria than what you see here. So it says, who are your friends on this slide? This just fits nicely in this diagram. And then using this information, so using people's nominations of their friends or people who they interact with regularly and socialize with regularly, we can map out the friendship network of the community. So the different colored circles here represent different people, and the lines are different friendships between them. And doing this allows us to get a rich set of information about people without having to ask them much beyond just who their friends are, and without having to necessarily clue them in to what the rest of our studies are going to be about. And so from this data, we can ascertain things like if someone tends to have a lot of social connections, if they tend to be really well connected to other really well connected individuals, if they tend to bridge between otherwise disparate, disconnected cliques or groups of people, and how much social distance exists between them and each other person in the network. So in other words, how many degrees of separation they are from everyone else. And I'll come back to these various individual difference variables later and how we can link them to neuroimaging data. But essentially, in a really broad sense, we can have some or all of these network members come into the lab for behavioral or neuroimaging studies or a combination thereof. And then we can ask questions like, how much do we know about where other people sit in our real world social networks? And do our brains retrieve this knowledge when we encounter other people so that this knowledge can shape how we think and how we'll act? So you may know that a lot of past research on social perception has used oftentimes anonymous or very artificial stimuli, but by using somewhat more naturalistic stimuli like photos or brief video clips of people who participants actually know, we can begin to answer questions like these. And we can also ask questions about if the ways that we process the world around us is related to where we sit in our social networks or the ways that our social networks are organized. And so starting with this first family of questions, we can break this down into specific questions about how people process information about their real world networks, like how much do we know about where other people sit in our real world social networks? And do we retrieve this kind of knowledge spontaneously when encountering one another, so that can help us gear up for appropriate and beneficial social interactions when we're going about our real world day-to-day lives. And there's some reason to think that this might be the case. So other aspects of our knowledge about familiar people, things like personality traits, for example, are thought to be spontaneously activated when you see someone or when you encounter someone who you know. And the purpose of activating this knowledge is thought to be preparing you for adaptive and effective social interactions. So this allows you to sort of seemingly effortlessly sort of shift gears depending on who you happen to be around. And information about social ties, like whether someone's a friend or a friend of one of your friends, or characteristics of their broader position in your real world social network, like how well connected they are, these things also likely inform our behaviors and our perceptions. And while there's been a fair amount of work contrasting people's responses to people who are familiar to them versus strangers, with some notable exceptions, there really isn't very much at all known about if and how people encode and are affected by specific social relationship information about actual familiar others from their real lives. And yet these are the people, so your friends, your coworkers, and so on, with whom the bulk of your everyday social interactions tend to take place. And so to begin to get at this, in the first study that I'll tell you about in this section, we took all of the first year students in an academic program, so about 300 people, and we reconstructed their social network simply by asking them to answer this survey question about who they socialized with most often as part of a classroom activity that they didn't know would be related to an fMRI study that they would be recruited for a few weeks later. So the prompt was, consider the people with whom you like to spend your free time. Since you arrived at this institution, who are the classmates you have been with most often for informal social activities, such as going out to lunch, dinner, drinks, films, visiting one another's homes, and so on. So students essentially just named their friends, and then using this information, we can map out the social network of the cohort. So all the circles here are students, and all the lines are social ties between them. And the properties of students' positions in such a densely connected network are pretty hard to visualize in this way, especially when showing all the people and all the relationships between them kind of just looks like some big ugly hairball. So when visualizing the social connections between members of this program, the point here is not to illustrate things about the network itself. It's really just to illustrate the procedure of the study, where we characterize a social network of relationships between all these people, and then we're going to take a subset of those people and get some fMRI data on them. But first, to quickly go over some of the key aspects of social network position that we're interested in, I'm going to use a simple toy network of about 13 people. So one important consideration is social distance. So this is pretty easy to get at. It's just like playing the 6 degrees of separation game. So for any participant, like for example, Mary, we can see who she's 1 degree of separation from, like Tim. And you can see that she's 2 degrees of separation from someone else, like for example, Luke here. And we can play this game for everyone in the network and map out how far each person is from Mary. And you can imagine how this information might shape Mary's behavior. The actions, the thoughts, and the feelings of people closer to her will be more relevant to her, perhaps, than people who aren't directly connected to her or to people in her immediate circle of friends. So Mary might be more likely to tune into them in everyday life. And so that's one aspect of other people's real world social network position that might be behaviorally relevant in everyday life, social distance from us. We can also extract other important aspects of sociality from the patterns of ties in this network too, like for example, how well connected each person is to well connected others. And this might be especially important for us as humans, because for us, our power to influence other people and things like conflict resolution and resource allocation, these things depend not just on who is strongest or most dominant, or even who's most prestigious or knows the most. If a person has others who support her, who in turn have lots of other people who support them, they gain a kind of certain power or status. And we define social status here in terms of how well connected each person is to well connected others, or eigenvector centrality. So the people high in eigenvector centrality are sort of big fish in big ponds socially, like Bob here. So even though Bob and Tim both have 4 friends, Tim's status in this sense is lower because his friends aren't as well connected. And this is similar to how Google decides which pages to rank first when you do a web search. So a link coming from my web page isn't as valuable as a link coming from somewhere like the New York Times to your website. And in a similar way, Bob's link to Leah is more valuable than Tim's link to Amy. And another individual difference variable that's related to sociality that we can extract from the patterns of ties in this network as well is who connects otherwise separate people in the network, or in other words, who tends to occupy a minimally constrained network position. And so people who do this are known as sort of social bridges or brokers. So you could think of someone like perhaps Tim here, who in high school might have been the kind of person who would be friends with people in lots of different cliques or could kind of move in different social circles with ease. In contrast, Lisa, whose friends are both already friends with one another, is in a highly constrained network position. So compared to Lisa, Tim will tend to get more diverse information, and he's also more likely to be somewhat of a social chameleon, so to speak, who adjusts his behavior to fit with different social contexts. So we can also characterize how constrained everyone is in this network. And so we all vary on how well connected we are and how constrained we are in our social networks. And of course, we're closer to some people than we are to others. And so together, these features build up much of the structure of our social sphere. So we can take everybody in our network and characterize them in terms of these 3 attributes. And as I said before, this allows us to get a rich set of information about these people without having to ask them all that much beforehand, or without having to cue them into what our study is really going to be about. So in this case, we took 21 people out of this network, so the nodes you see here colored in peach, and we had them come into the lab for an fMRI study. And for each fMRI study participant, we can look at the network from their perspective and see who's 1, 2, or 3 degrees away from them in the network. And we tailor-made a stimulus set for each person that contained 12 individuals, the 2 highest and lowest eigenvector centrality individuals at each of 3 distances from them in the network. So the 2 smallest and largest nodes in each layer here represented by these little silhouettes on the other side of the slide. And then for everyone in each stimulus set, we had a short video clip of them saying essentially the same thing. So really just introducing themselves, which we showed to participants in the scanner. And so they just each watched videos like this with the fixation cross in between. And they just pressed a button whenever they saw the same person twice in a row, just to make sure they weren't falling asleep on us. So these brief video clips of their real world friends and acquaintances could be thought of as sort of akin to the kind of perceptual experience you might have when you encounter people out in the world in your day-to-day life. And then after scanning, there was a questionnaire that probed how accurately participants perceived other social network positions. And looking at that data, so each line is a participant and perceptions are on the y-axis, reality is on the x-axis. In all three graphs, you can see they're quite positively related. So as you can see, people seem to know a lot about where others sit in their real world social networks. But is this knowledge retrieved when we see these people? And so to get at this, we used a searchlight approach. And since from what I understand, there's a variety of attendees registered for this workshop. So a nice number and variety of people who have varying interests and backgrounds, I'm sure. I'm just going to quickly walk through what we did in a pretty general high level sense. So we just moved a sphere through each person's brain. And then at each point in the brain, we extracted the local response pattern to the person who they were seeing on the screen and to every person who the participants saw while they're participating in the fMRI study. And so different people in the participant stimulus set are represented by these different rows here. And then these squares just represent activity within each voxel while seeing that individual. And I've just strung the voxels out horizontally to represent a response pattern in this brain area or sort of little local neighborhood for each of the 12 people in the participant stimulus set. And essentially, we compare these patterns to one another to construct this neural similarity structure, which is just like a correlation matrix that gives us a sense of what information a brain region is encoding. So what kinds of things it treats as the same, what kinds of things it treats as distinct, and by how much. And so we can construct this neural similarity structure that's sometimes referred to as a brain region's information signature, since it captures what distinctions this region does or doesn't care about in your stimulus set. And then we can go back to the social network data and construct similarity structures based on 3 measures of sociality that I went over earlier. And because now we've summarized the patterns from the brain data and the social network data in a way that's abstracted away from how we acquired this information, it's just 12 by 12 matrices indexed by individual, we can do things like take the neural similarity structure at any given point in the brain and model it as a weighted combination of the 3 similarity structures from the social network data. So we can do things like see if there's anywhere in the brain where these aspects of someone's position in your real world social network are encoded when you encounter someone who you know from your actual day-to-day life. And so here, the colors here show what seems to be encoded in a given brain area. And without getting into too much sort of wildly speculative reverse inference, some of these point to sort of testable hypotheses about the underlying processes that might be differentially triggered or influenced by social network position information when you encounter people who you know in your everyday life. For instance, information about eigenvector centrality or how well connected others are to well-connected others in your social network is carried in brain regions that are associated with, among other things, mentalizing or thinking about other people's thoughts, in other words. And this suggests that being well-connected to well-connected others, like other aspects of social status, may impact the extent to which we attend to others' internal states. And I'll just quickly tell you about some work where we're sort of testing this notion. So one simple way to measure attention to others' mental states is with gaze cueing paradigms. In case anyone's not familiar with those, I'll just quickly demonstrate what they entail. So the participant's job is not very exciting, and so this aspect of the paradigm is not very naturalistic, other than it does contain images of people who participants actually know, but it's pretty artificial, so people just watch the center of the screen and indicate whether a target, shown by the T here, appears on the right or the left. And the only catch is that right before the target appears, a face appears, and that's either gazing to the right or to the left. And even though the direction of the face's gaze has nothing to do with where the target appears next, and participants are aware of this, they're faster to respond correctly about the target's subsequent location when the cueing face had just been looking where that target later appeared. So in the valid trials shown on top here, compared to when the face had just been looking in the opposite direction. So in the invalid trials, you see on the bottom here. And the gaze cueing effect, so you being faster to respond correctly on valid compared to invalid trials, arises because we automatically track and shift our attention toward where other people seem to be attending. So to what other people seem to be thinking about. So the strength of this effect reflects how much you're attending to the apparent mental state of the cueing face. So if we do really attend more to the apparent mental states of exceptionally well-connected people in our real world social networks, then these people's faces should exert stronger gaze cueing effects. And so to test this, we characterized the social network of a new community, and we had as many of them as possible come in to get photographed to make stimulus sets for the gaze cueing study, where the participants were fellow group members shown in peach here. And I'll just quickly show you some of the key results. So the gaze cueing effect is on the y-axis here, and the eigenvector centrality of the cueing faces on the x-axis. And as you can see, the faces of better connected people are exerting stronger gaze cueing effects. And this fits with past findings suggesting that social attention is modulated by other ways that people often operationalize social status as an individual difference variable, like, for example, the apparent masculinity or physical formidability of faces. And that's arguably because those individuals are more behaviorally relevant to perceivers, making their mental states and behaviors especially important to predict and to monitor. And so social network centrality also seems to modulate social attention. And this makes sense if you think about it, given that well-connected people are especially influential when it comes to all sorts of things that are important in day-to-day life. So things like spreading information and setting norms and shaping reputations. So especially for people like the individuals we often study. So for example, students in college campuses, people with relatively peaceful day-to-day lives, how well connected others are might be a facet of social status that's especially behaviorally relevant to everyday life. And so this is just one example of how real-world social network knowledge, once retrieved by the brain, might be an important individual difference variable regarding the people who we encounter in our everyday life. And then that goes on to shape downstream processing and behavior. And we can also use the kind of general approach that I outlined at the start of my talk to ask questions about if how our brains process the world around us is reflected in where we sit in our real world social networks. So for example, many of us have the intuition that we're friends with others who are like us, or that birds of a feather flock together, as the saying goes. And this is by no means a new intuition. It goes back at least to the 1500s. And sociologists have confirmed this. So across cultures and contexts, humans tend to be surrounded by others who are like them in terms of a whole range of factors, things like age and gender and so on. And this tendency is called homophily, or love of the same. And it's been suggested that homophily might be beneficial because it might facilitate things like collective action and cohesion and empathy, since similar people are more likely to share assumptions and goals and experiences. But this explanation hasn't really been tested directly. And in the same vein, you might have an intuition that your friends aren't just people who fulfill certain demographic criteria, like same age, check, same race, check, same gender, check. Within demographic groups, we of course resonate with some people more than others. And hopefully you have some friends who fall into different demographic categories than your own. But until relatively recently, a lot of the evidence for homophily has been based on pretty coarse variables like demographics. And this is despite the perception that a lot of us have that our friends are people who we sort of click with. So people who respond to things like we do and who see the world from a similar perspective to our own. And so here we want to test that notion. And one window into how we respond to the world, so into our thoughts, our emotions, and how we allocate our attention as these processes unfold, is provided by neural response time series. And as you know, this has been shown in some really impactful and important work done by other speakers in this workshop. So for example, some really elegant work pioneered by other presenters in this workshop, such as by The Hassan lab has shown that if you take a group of people's brains and you align them to a common anatomical grid and then show them some engaging dynamic stimulus like a movie, then if you extract the time series of neural responses from corresponding locations in the brain as they watch the movie, their brain responses sort of become locked together in time. And so this is just a cartoon schematic meant to show that. And the similarity of people's neural response time series reflects similarities in things like their interpretations and what they focus on or attend to, and their emotional reactions and how captivated they might be, and so on, depending on where you're looking in the brain, of course. And so if we are exceptionally similar to our friends in how we attend to and interpret and respond to the world, we'd expect our neural responses to rich real-world stimuli to be particularly similar among friends relative to people who might know one another but not end up befriending one another. And so to get at this, we again characterize the full friendship network of another graduate program. And we had a subset of these people, again, come into the lab for an fMRI study where they just watched a set of videos. And we had a few criteria for choosing those videos. We wanted things that participants hadn't likely seen before, to avoid, for example, similarities among friends just being inflated because people would have seen the same things together before, maybe, gone to a movie together or something like that. We also wanted things that would be engaging so that they'd hopefully recruit a good portion of the suite of cognitive and emotional processes that characterize our rich everyday mental lives, and also to minimize mind wandering, which could be a source of noise here if different people ended up mind wandering about different things, depending on maybe what happened right before they came in for the study. So these choices seek to minimize variability between participants due to thoughts that are just unrelated to the experimental context, so to the stimuli that we're showing them. But we didn't want to squelch intersubject variability completely, of course. We wanted videos that would still introduce some meaningful variability between people, because different people might interpret them differently or have different emotional responses to them or attend to different aspects of them. And so we wanted videos that would minimize uninformative intersubject variability by being engaging, but really promote more meaningful intersubject variability. And so we chose some things that some people might find really sweet and touching and adorable, that others might find kind of sappy or cloying or overly sentimental. We had some examples of comedy that might appeal to people with a certain sense of humor, but not others who might fail to appreciate or even detect the humor. So we had some examples of pretty sophomoric, very lowbrow humor, also some kind of slapstick or physical comedy, and some kind of wry, cringe-based comedy. We also used things that might be understood or parsed differently depending on people's pre-existing knowledge or interests. And we also had arguments that some people might really resonate with, but that might evoke skepticism or even contempt in other people. And just to give you a sense of participants' experience, I'm going to show you some brief excerpts of some of the clips that they saw in the scanner. And in the interest of time, these excerpts have all been trimmed to just be a few seconds long. But in the actual study, each clip was at least a minute or two long. So these are just some brief slices of some of the things that we showed to participants.
When I was outside on my first spacewalk, I was on the dark side of the world over the Indian Ocean.
And by having workers who only had to do one thing, they could pay them a low wage, and it was very easy to find someone to replace them.
The water squeezes out of the cloth, and then because of the surface tension of the water, it
is insulting when a coach is making 5 to 10 to 15 times more than a college president.
These babies are not strong enough to cling, and they fall to the ground repeatedly.
It's at times like that you don't often think of funny things to say, but I did. And I turned to the rescue workers and I said, talk about a rough day at work. That was referring to spending the time up there being pretty rough. Talk about a rough day at work.
Okay, so again, each clip used in the actual study was about a minute or so long. Those are just trimmed for to fit in the time that I've allotted today, and that's just a subset of them. And so while participants watched videos like that, we measured how activity across the brain rose and fell over time. So on top, you see data from 2 participants, and on the bottom is this activity summarized for a given brain area for the same 2 participants. And it's of course been sped up a bit for visualization so that I don't have to linger too long on the slides. Or unfortunately, we don't have this fine temporal resolution with fMRI, but you can sort of see that it often seems to be the case that these 2 people are relatively in sync with one another. They also happen to be friends. So we wanted to see if in general, people who are friends and who are closer to one another in their real world social networks would have more similar neural responses to naturalistic stimuli. And so to get at this, for each pair of fMRI participants, we parcellated their brains into constituent brain regions using just anatomical ROIs delineated with free surfer reconstruction. So different regions are shown in different colors here. And then we measured the similarity of their neural response time series in corresponding brain regions as they watched the videos. And so then we can go back to that social network data and we can see how close together each pair of participants is in the social network. And then we can relate that social network proximity to their neural response similarity in each brain region. So for each pair of participants, we also have these 80 values capturing the similarity of their neural responses across 80 anatomically defined brain regions. And we go back to that social network data and see if they were friends. So if they're characterized by a path length of 1 here, or friends of friends, so characterized by a path length of 2 here, or farther removed from one another in the network. And so we just label those accordingly, as you see here. And I'm just going to show you some descriptive statistics to give you a sense of the overall pattern of results. And I should note that all the things I'm going to be showing you are results that are taking into account similarities in all the demographic variables that we were able to get our hands on. So here, warmer colors are going to be more similar than average for a given brain region, and cooler colors are going to be less similar. So for people who are 3 degrees of separation from one another in the network, so people who are friends of friends of friends, we're seeing cooler colors throughout the brain, suggesting that these people are responding to what they're seeing pretty dissimilarly to one another. The opposite seems to be true for distance 2 diets. So here we're seeing warmer colors, suggesting that these people who are friends with one another's friends, but not with one another, are responding to the videos more similarly than pairs of people who are farther removed from one another in the network. And then if we look within friends, we see warmer colors, indicating that these people are responding to what they're seeing in an exceptionally similar way. And this pattern is especially pronounced in regions that determine things like how we allocate our attention, like the superior parietal lobule circled here, where friends are especially similar to one another, and then the similarity decreases with increasing social distance. We also see a similar pattern in regions like the angular gyrus, where others have shown that similar neural response time series are associated with similar high-level interpretations of situations. So to return to our earlier question, do we respond to the world like our friends do? It seems that we do tend to be surrounded by people whose brains respond to the world similarly to our own. And so now going forward, we're doing further work, including longitudinal studies that will allow us to ask questions like, do we become similar to our friends over time and sort of align ourselves with the people around us? Or do we become friends with people who are already like us in terms of how they respond to and presumably see the world, and in what ways? And so we're currently working on longitudinal research looking at these sorts of questions. And we're also working on some projects where we're using more constrained fMRI and behavioral paradigms that aim to clarify what kinds of processing of what kinds of stimuli might be driving these sorts of effects. And on top of this work on how your brain processes information about the world around you, in other work, we're finding that we even see similarities among friends when people aren't seeing anything at all. So this builds off work that people in this meeting have advanced and pioneered, suggesting that we each have our own distinctive resting state functional connectomes, which are related to individual differences in various characteristics, including how we tend to think and behave. And we've recently found that our resting state functional connectomes are also particularly similar among people who are closer to one another in social ties, especially among people who live close to one another and can interact with one another more readily. As you can see here by this red line, that's steeper than the others. And so this data was collected on residents of a small island village in South Korea, where in work done with our collaborators there, including Yusuk Yoon and Jinyoung Chae, we have acquired participants' brain data and also their social network data, and also information about where they live in the village, so where their homes are located. And we see that even after accounting for things like demographic and personality similarities, as well as kinship, so the sorts of things we can readily measure with sort of typical self-report surveys, people who have more similar resting state functional connectomes tend to be closer together in the village's social network. And this relationship between social network proximity and neural similarity being particularly pronounced among people who live closer together makes sense if you consider the fact that people who are closer to one another, both in terms of space and in terms of social ties, might have more chances to influence one another and perhaps would be more likely to find themselves in common environments and situations that might influence them both similarly. And also there's the fact that people who live far from you might be a mix of people with whom you aren't really compatible and people who you might be friends with if they live closer to you, and interacting with them was a little bit easier. So all of these various factors could contribute to this relationship between social network proximity and neural similarity that we see being more pronounced for people who live especially close to one another. So just to briefly sum up, hopefully what I've shown you today is that people seem to have pretty accurate knowledge of where others sit in their real world social networks. And we retrieve this knowledge spontaneously when we encounter one another. So when we see naturalistic depictions of people whom we know. And consistent with the notion that a key reason that we spontaneously retrieve any kind of person knowledge at all when we see someone whom we know is to sort of prepare to think and act in an appropriate and beneficial way, social network centrality seems to gate social attention in humans such that we pay more attention to what well-connected people from our real-world social networks seem to be thinking. And we seem to be exceptionally similar to people who are close to us in social ties with respect to how our brains process the world around us, and also with respect to our patterns of functional connectivity measured at rest. And so I think that by combining these sorts of traditionally siloed approaches from social network analysis, psychology, and cognitive neuroscience, we can open up a lot of what I think are really exciting questions, because if we really want to understand social thought and behavior as it unfolds in naturalistic circumstances, so out in the real world, we can't always just treat individuals as isolated units or really even as dyads or pairs of people and expect that we're going to be able to tell the whole story. Even when we're just looking at two people having a conversation or one person viewing another person, what's really going on under the hood, so both how they're perceiving and reacting to one another, how they're influencing and being influenced by one another, these things seem to take into account this rich fabric of social ties in which each of us is embedded. And so I'd just like to quickly thank you for your time and attention, and thank the organizers once again for putting together this workshop.